Today we are going to listen to 5 presentations, and each will take about 10 minutes. And I'm going to be the moderator, so I'm just going to say a few words. So just a few general instructions, as you probably already know. So please have your cameras and microphones off during the lectures. Please write your questions and comments in the chat. And we will also take a short question after each talk if there will be enough time, but hopefully there will be. And the main discussion is planned after the last talk. And also this event will be recorded and then available at this link. And also the registration form is available. So just a few words about where is Slovenia. So Slovenia is located in the center of Europe along the Adriatic coast. It has a cold western part due to karstified rocks. So the name Kras in Slovenian is actually karst, as you all know. And although it is not a big country, there are also some touristically attractive high mountains in the north and northwest with the height of approximately 2,000 to 2,800 meters. And the warmer part of Slovenia is in the east. Okay, why is this not working? Oops, okay, I don't know. There should be one more picture. But the warmer part of Slovenia is in the east with the Pannonian Basin flatlands. So that's all. And now we can continue with our presentations. Okay.
Do you see my presentation?
Yes, thank you. So yes, we see everything. So our first speaker is Dusan Rajver. He is a research and development associate at the Geological Survey of Slovenia, a department for regional geology. He took additional postgraduate course at the International School of Geothermics at the International Institute for Geothermal Research in Pisa, in Italy, in 1990. And he also received his master's degree thesis on geothermal characteristics of the Krško Basin with emphasis on geophysical investigations. He has a lot of experience in measurements of geothermal parameters and their interpretation, heat flow studies, mapping, and many other fields in geothermal, both from thermal water and from shallow underground. And today he is going to talk about use of geothermal energy in Slovenia for heating and cooling in 2021. So thank you.
So hello everyone, good afternoon, good morning. So I will speak about overview of the use of geothermal energy in Slovenia for heating and cooling in the last year. And oh, I understand it. Okay. So geothermal energy use in Slovenia is only for direct heat use so far, and it is based on using the heat from thermal water from deep thermal aquifers with 53 production wells and one operational reinjection well at Lindava, which is in northeastern part of the country, and with 4 natural thermal springs. And the temperature of the used thermal water is from range from 20 to 76 degrees, and the highest temperatures are, as you see on the map, in the northeastern part.
Sorry. It doesn't change. Can you check the view again?
Probi nastaviti še enkrat. Zdaj pa za mene še pogled, ja. Okay.
This is okay now?
Yeah.
So, all right. The use of geothermal energy in Slovenia is based on the direct heat use only so far, with withdrawal of thermal water from deep thermal aquifers, and this was 9% higher than in year 2020. But in 2020, the withdrawal of thermal water was by 33% lower than year before due to COVID pandemic. And this caused that in several thermal spas and thermal resorts, the withdrawal of thermal water was much lower than years before. So this use of heat from thermal water is going on in 53 production wells and only one operational injection well, as I said, and 4 thermal springs. Drilling activity was quite modest in the last 6 years, with only 1 new well at Terme Čatež in the eastern part of the country and 3 shallow reinjection wells. On the smaller map on the right, you see the position of all boreholes deeper than 1 kilometer in the country, both thermal wells and research boreholes for hydrocarbon and other research activities, like, for example, gas storage. So utilization of geothermal energy for direct heat use is based on deep and shallow geothermal energy. Total capacity of all applications is almost 300 megawatts, and the annual geothermal energy used is about 1,657 terajoules, which is by 42% increase in 6 years. And this is by 7% more than in 2020. This equals 0.62% of gross domestic energy consumption at level of primary energy supply in the country. So direct heat use from thermal water is going on at 31 localities, all pictured on the map. And installed capacity is about 16 megawatts. So annual thermal energy used at all these localities is about 472 terajoules. And on the map, you see the different categories of utilization of this thermal water, with individual space heating and bathing and swimming at several locations, and district heating at only 1 location in Lendava, and 3 greenhouses, or at some localities only individual space heating, and at several locations for bathing and swimming, or swimming pools. But the share of shallow geothermal energy use is much higher now. In the last 8 years, it increased over 50%, and it covers now about 71% of all geothermal energy use. But due to COVID pandemic in the last 2 years, on the lower graph, you see that the utilized energy with other geothermal applications is a little bit lower than years before. On the right side, you see a little bit different map, which is based on geothermal applications set by the recent country update tables for the next World Geothermal Congress. So again, shown users for where thermal water is used for agriculture and food processing, and several localities where thermal water is used for health, recreation, and tourism, This is for basically for bathing and swimming, and for heating and cooling for buildings, or separately only for this application. And at 3 localities also thermal water is used for snow melting. This is a summary in this table shown with these geothermal applications according to this new setting. But it's easier to watch only the graph on the right side with showing that for agriculture and food processing, 119 terajoules is used, and for health, recreation, and tourism, or bathing and swimming, 140 terajoules. And altogether, these two, together with individual space heating, district heating, air conditioning, and domestic hot water heating, the total is 472 terajoules. While on the other side, the usage of shallow geothermal energy is about 1,185 terajoules. So this shallow geothermal energy use with the ground source heat pump technology is going on with at least 14,800 operational units, both water source and closed loop ground coupled systems, which is about 58% increase in 6 years period. And their total capacity is about 238 megawatts. So the used energy is about 1,185 terajoules for heating mode. And in the cooling mode, we assume that at least 240 terajoules is rejected to the ground. We try to distinguish between small systems and big systems. Small systems with rating power of less than 20 kilowatts, they count approximately 94% of all systems, and 71% of all thermal energy use is with these systems. While big systems with over 20 kilowatts of rated power, they use about 29% of all thermal energy use from the shallow underground. Altogether, we can say that the number of water source units is increasing constantly, but in the last years, especially the closed loop systems with borehole heat exchangers is increasing faster, which is visible on the right graph. With open loop systems, we need to, of course, drill pumping wells, which are pretty shallow in the northeastern part of the country where the geological conditions are the best, while in the other regions of the country, their depth is slightly higher. The share of big units is almost 10%. Closed loop systems with horizontal collectors are mostly, almost entirely, only small units, while closed loop systems with borehole heat exchangers are also mostly small units, but the share of big units is almost 7% now. I will conclude with some summary notes. Geological Survey of Slovenia has a unique and reliable database on geothermal energy use in Slovenia, and annual overview is published at Bilten Mineralne Surovine, or mineral resources. In the last 10 years, only 3 new geothermal wells were drilled, 2 of them for doublet, but they're not in use yet, and 1 of them is for production. New reinjection wells are planned in the very near future at 2 users in northeastern part, but several wells drilled a couple of years ago still wait for investors. The promotion of direct use is focused on faster and more transparent granting of concessions, improvement of utilization records and public information, establishment of state monitoring of geothermal aquifers, improvement of energy efficiency by cascade use, and coordinated cross-border management. And this was supported by projects TGM, TransEnergy, Darling E, GeoMol, GeoEra Hotline, and GeoConnect 3D, and Geothermal DHC, which were going on together with neighboring countries, especially Hungary, Austria, and Croatia. Very few new potential locations were investigated. But promoting the use of shallow geothermal energy was more successful and also supported by European projects such as GeoPower, GroundMed, Legend, Greta, GeoCE, Geoplasma Central Europe, GeoEra, Muse, GeoCool Food, and these were also going on with mostly neighboring countries and some countries from the Alpine space, for example, in Greta project. We created content for training installers of heat exchangers in the shallow subsoil, and we also produced the guidelines for shallow geothermal drilling down to depth of 300 meters. Thank you so much for this, for your attention.
Okay, thank you, Dusan. It was a very interesting presentation. Now, are there any questions? Please go ahead. You can write, or if not, then we can continue to our next lecturer, who is Simona Adrinek. Simona is a young researcher at the Geological Survey of Slovenia, working in the field of geothermal energy. Her PhD research is based on studying the influence of geological factors and hydrogeological conditions on the possibility of using shallow geothermal energy. She took additional training in measuring thermal properties at Polish Geological Institute and Norwegian University of Science and Technology. And today she is going to talk about shallow geothermal potential. So please, Simona, go ahead.
Okay. Do you see the presentation?
Yes.
Okay. Hello. In this presentation, I will briefly talk on, let's say, different topics, but all related to the shallow geothermal energy in Slovenia. First, I will quickly present you the two past projects that our survey was involved in. One of the many outcomes for both projects were really user-friendly web pages where you can find the first impression of the shallow geothermal potential in Slovenia. Then I will also present the ongoing cost action, which is more focused on networking and knowledge exchange about the geothermal energy. After that, we will go through our natural conditions that are influencing the potential, so geology, hydrogeology, and temperatures. And I will really shortly try to present you the main legislation procedure for the shallow geothermal potential. And at the end, I will also show you some of the results from numerical modeling of already existing open-loop systems in our municipality in northeastern Slovenia. Let's start with the project Geoplasma. Abbreviation stands for the planning, assessment, and management of shallow geothermal energy in Central Europe. The project duration was from 2016 to 2019 and included 6 countries with Austria as a lead partner. The achieved outputs cover harmonized workflows, strategies, and joint quality standards, as well as joint web platform with all pilot areas. In Slovenia, pilot area was our capital city, so the municipality of Ljubljana. You can see it on the picture. And this web page gives you an overview over the geothermal potential, possible conflicts, and the geological units which can be found down to the 200-meter depth. Still, maps do not serve, of course, as a planning basis for the dimensioning of installation, but give you a first impression whether the installation is even possible or forbidden, or whether an individual decision is necessary. Then the next quite similar project was Greta, which focused on, they call it near surface geothermal resources in the territory of the Alpine space. The duration was from 2015 to 2018 and included 12 partners from 6 EU countries. The main results were decision support tools, so geothermal potential maps, guidelines for energy planning, legal and technical guidelines for the utilization of potential in the Alpine space, and also in the Geotheroom municipality, which was the pilot area in Slovenia. They established the geothermal educational train. So important here was also that municipality supported the integration of the project results to its spatial plan and local energy action plan. And also they created the web page where you also can get the first impression if identified closed loop geothermal potential cover the required energy needs. Then still ongoing project, but quite different, is the cost action geothermal district heating and cooling, aiming on research network for including geothermal technologies into decarbonized heating and cooling grids. The action mainly covers the networking, knowledge exchange and transfer, training, stakeholder interaction activities based on real-life case studies. From a technical point of view, action addresses different topics, not only shallow geothermal energy, they are listed below, but I will not go through them. And by the end of the action, 5 main outputs will be available. Still, again, they are listed below. And they are all related to the quicker inclusion of geothermal energy into heating and cooling grids. And you're also welcome to join this action. Anyone can join, just visit the web page and click join in, and then you will get all the information about the ongoing activities, and you can join, and of course you're welcome to actively cooperate. Okay, now, yeah, moving to the natural conditions that prevail in Slovenia. And also influence on the installation of shallow geothermal applications. So from the geological point of view, shallow subsurface in Slovenia is dominated by sediments and sedimentary rocks, which account for about 93% of the surface. Among them is 50% of sediments and sedimentary rocks, and 40% are carbonate rocks. The other small part are metamorphic rocks with 4% and igneous rocks with only 3%. On the bigger figure here, which represents the mentioned basic geological units, I added the locations of the open and closed loop systems installed from 2016 to 2020 and gathered in the EcoFund database, which only contains systems that were subsidized and mainly have the capacities lower than 20 kilowatts. So definitely these are not all of the systems that were installed in this period, but I just added it on the picture to get a general feeling how they are, let's say, spatially distributed. Yeah, the first thing that we can see is that the locations are related to the population density, of course. The population density is shown in the smaller picture. So the red areas are the areas with a higher population, and also, of course, there we can observe more installed systems. But still, number of open loops, the higher number of open loops is on the areas with clastic sediments, which is further related to the aquifers, and while closed loop system spreads also on other lithologies. So the distribution of the systems is, of course, closely related to hydrogeology. The highest open loop densities are located on the areas with our biggest intergranular aquifers. Important here is also that groundwater is the main source of drinking water in Slovenia, meaning that 80% of our territory is protected by drinking water protection zones. So systems that are planned there require more strict legal procedure. But let's stay at some basic informations. Groundwater temperature is typically between 10 and 15 degrees, and the groundwater table is on average between 2 and 25 meters below the surface, of course, in intergranular aquifers. In some parts of Slovenia where aquifers are confined, also iron and manganese are present. So so the more precise technological approach is needed when installing the systems. And in the parts with unconfined aquifers, the risk of calcification or corrosion could also be a problem for open loop systems if groundwater temperature changes exceed 5 degrees. Okay, and here are just presented the maps of the temperatures of the underground at the depth of 100 meters and 250 meters. We can see that Dusan already showed some of the maps, but we can see that at 100 meters, the temperature is, let's say, on average 12 degrees, and 3 degrees higher if we go more to the northeast. These temperatures are not high, but still enough for the efficient use with the heat pumps. Some same distribution can also be observed at 250 meters with slightly higher temperatures, of course. Okay, now regarding legislation. In Slovenia, shallow geothermal is defined up to a depth of 300 meters, which is related to our Mining Act, according to which a mining project is required for wells deeper than 300 meters. Otherwise, the legal basis for the installation and use of shallow geothermal energy is the Water Act. For both systems, the research permit and water consent must be obtained if the wells are deeper than 30 meters or are located in the drinking water protection zone. Regardless on the borehole depth for open loop systems, also a water right must be obtained. And regulations on drinking water protection zones depends on which among 4 zones we are. In abstraction and inner zone, no research permits for boreholes can be granted, while in the middle and the outer zones, the acquisition of water rights depends on the regulations for specific water source and corresponding risk analysis. We also have a special type of protection zone for artesian aquifer, where only closed loop systems are allowed. So this will be really briefly. And moving to the last part, so the numerical modeling of open loop systems. We did that in the municipality of Murska Sobota. You can see I don't know if you see my cursor, but the red point here. So the municipality of Murska Sobota is located in northeast Slovenia. And here the use of open loop systems really increased in recent years. By 2022, almost 1,000 water permits had already been granted. These are red dots on the bigger picture. The high density of these open loop systems is related to the presence of highly productive intergranular aquifer, whose dimensions are on the figures below. This aquifer has an average groundwater temperature of 12 degrees, and groundwater level is on average. So for this our special area on 3 meters, the spatial density of the installed open loop systems is very high in the city center of the municipality, which raises the question of potential mutual interference between the systems, and also the question of how many more systems can be installed. Therefore, we established a monitoring network in December 2019. We installed 15 probes in the existing pumping and injection wells that provide us with the continuous data on groundwater temperature and water level fluctuations. And therefore, the main aim was to create a numerical groundwater model, groundwater flow model, and heat transfer model for this area in blue lines, which allow us to evaluate the impact of these open loop systems, of chosen open loop systems. Based on the monitoring network, we get continuous groundwater level and temperature data. Groundwater levels of the pumping wells are on the upper graph, and their temperatures are below. And with this data, we were then able to calibrate the model in the steady state conditions and transient conditions using the FIFLOW program. On the right picture, we can see that the groundwater levels and temperatures after the calibration of the model in the steady state. And below is the cross section from going from northwest to southeast, showing so from the top to the bottom, showing the elevation, groundwater level, and the groundwater temperatures. So with the model, we were able to observe the distribution of the thermal plumes from the selected open loop systems. We can see that downward from the injection wells, so the blue points, the thermal plumes spread between 100 to 200 meters, which is affected by of course, by the rate of groundwater injected, and also the decrease in its temperature. The transient simulations showed that groundwater temperatures are restored in summer when the systems are not in operation. And also we can conclude that at the moment there is no significant negative mutual interference between the systems, although we can see that thermal plumes merge at certain locations or reach the catchment area of another pumping well, but this change is less than 1 degree on average, so does not affect on the overall efficiency of the systems. But for the future, due to the already high density of these systems, simulations of thermal plumes of new systems are proposed before they are installed. Of course, to avoid the influence on the efficiency of already existing systems. And so that would be all. For the end, maybe just to conclude what are the main activities of our geological survey related to shallow geothermal. So we perform basic shallow geothermal research and plan sustainable use of geothermal energy in the different national and EU projects. Besides that, we are also involved in applicative projects. So meaning that we are doing the maps of shallow geothermal potential at any location in Slovenia based on archive data or with detailed thermal property measurements using needle probe, optical scanner, or we are also performing thermal response tests. And we also do the planning of shallow geothermal systems, so starting with the analysis and evaluation of the thermal parameters. We can perform feasibility studies and do different simulations and dimensioning, of course, of these systems to support the decision making, to support investors at the decision-making phases. We use Earth Energy Design Program, Groundwater Energy Design Program, or for the numerical simulations also FIFLOW. And that would be all from my side. Thank you.
Thank you, Simona. So now there is one question from Philip in the chat. So what is the minimal geothermal gradient value in groundwater heat pump systems that is still good enough? And are heat pumps dimensioned for heating or cooling seasons?
Sorry.
Do you see, or do you want me to repeat? Okay.
No, again, I'm just reading the question. Yeah.
Okay.
Yeah. So mainly what we know from the practice, the heat pumps are dimensioned for the heating purposes, not so for the cooling. Although in the last year also this is started to become more how to say popular. And about the minimal geothermal gradient value, you mean what exactly is meant with that? Maybe we can also discuss at the end of the presentation, if is that okay?
Okay, yes, of course. Yeah.
Okay.
Okay, so then we can continue with Andrei Lapanie. So Andrei received his master's degree in 1996 at Faculty of Natural Sciences at the University of Ljubljana. Currently, he's a senior hydrogeologist with more than 25 years of experience in geothermal exploration, development and monitoring, well design and operation, geophysical logging, hydrogeological mapping and management of groundwater resources. And he is going to present managing transboundary aquifers. So,
yeah. Okay. So hello. I will talk about managing transboundary geothermal aquifers in Slovenia. We have just one of these, but let's start first with transboundary aquifers. Slovenia is located in Central Europe. It's a small country with an area extent of about 20,000 square kilometers. Okay, this one. Okay, so this one, and a population around 2 million people. To the north, we border with Austria. That somebody who is not from Europe should know. Austria. To the west with Italy, to the south with Croatia, and to the east with Hungary. In the past, we identify 11 potentially transboundary aquifers using this UNECE methodology, but we have only one joint transboundary groundwater body, which is officially declared and delineated, and this is the Karavanken karstic mountain transboundary groundwater body, which is mainly preserved because of its potential for the water supply and for the, of course, natural phenomena, because it's mountain regions, the mountains up to 2,500 meters. And on the expert level, transboundary aquifers are delineated and harmonized in southwest Slovenia here, with Italy in this karstic region, and with Croatia in this region, still going mostly for karstic aquifers. And we manage to have a common understanding about the transboundary extent of geothermal aquifer in the area connected with Hungary. And among all these potentially transboundary aquifer, only the latter is thermal, of course, and a small one I will show you later in this area with Austria in the basement. All others are mostly karstic here in this area. In 2014, in the scope of EU-funded project Transboundary, the Upper Pannonian Thermal Aquifer, which extends from Slovakia, which is further to the northeast, Austria, Hungary, and Croatia, were characterized according to the Transboundary Water Assessment Program of IGRATS, so International Groundwater Resources Center methodology. And this Slovenian-Hungary part of this Upper Pannonian Thermal Aquifer is, we usually addressed it as a Transboundary Thermal Groundwater Body, Mura-Zala. Its names about according to two rivers, and the river Mura is here, river Zala is somewhere here, and these are two sub-basins of this Neogen Pannonian Neogen sedimentary basin, which is very large. As it is seen from this slide, it was also the focus, this red one, was also the focus of many projects internationally in the last 20 years. And what is about legal situation? What was the situation for utilization of this geothermal aquifer in Slovenian part around 2015, and why we have to first cleaning up our doorstep before we entering the transboundary management. In the year 2015, the thermal water aquifer management in Slovenian part of transboundary thermal groundwater body Mura-Zala was not sustainable, not efficient. The utilization, which started in 70s of 20th century, from the sandy to loose sandstone upper Miocene aquifer, only with boreholes, was, as you see, was very it was not okay. Only 3 from 28 users in Slovenia at that time, not just in this aquifer, had concession for the utilization of this thermal water. And the monitoring of abstraction, water levels, temperatures, and chemistry at these utilization sites were not existent or very poor. There was a network of observation wells established in 2009 as part of PhD of our colleague Nina Arman, which you will know later. And this we called research monitoring. All these boreholes were self-flowing at the beginning because of thermolift. The hydraulic pressure is below surface, so it's not artesian aquifer, but with thermolift, in some occasion also gas lift. The wells were self-flowing at the beginning, and this self-flow began to decrease slowly, and there was necessity to install first centrifugal pumps and then submersible pumps, and then also to deepen the location of submersible pumps. And in some location also the change of water chemistry occur. And also we know that water level in this thermal aquifer regionally decreased. But we know this only from 2009, for sure. Since this water is mainly used for spad air, this water is not reinjected into the aquifer. And also those who use this water for heat, they don't do yet. it's quite a challenge also, because this sand or loose sandstone, it's not easy to reinject the water there, because also the movement of particles and the clogging is occurring, and also you need to back flush the reinjection well each year. So this is also the cost issue, but we are now dealing and hopefully next year we will be a part of one project where the reinjection well will be drilled, and we will do a lot of research also there to help the users with the design for injection well. We also, of course, noticed that there was a gap between reported abstraction of thermal water to the authorities and the amount reported to us, to Geological Survey, as a voluntary basis. As we see now, this gap, we managed to come very close. And I think now from 2016 on, we have just one, the same abstraction, which is reported to environmental agency. And because of all this, what I mentioned before, in year 2015, Geological Survey of Slovenia prepared for the Ministry of Environmental and Spatial Planning the guidelines for the management of thermal water aquifer. And the main aims of these guidelines are that we have to protect the aquifer capacity. If we wouldn't like to use this aquifer, not just for sometimes, but let's say for many years to come, and for those who will use it better than we did. And of course, in this area where we observed water level decrease, so negative trend, new abstraction for heat are allowed only to use by doublets. And of course, the use of heat by the doublets is promoted over the use of water for use of thermal water for the spa. So even for the spa, even for the pools, we said use the heat exchangers and then reinject the cooled water. Don't put thermal water in the basin, not all amount you need. And of course, we also promote the increase of efficiency of use, thus decreasing the abstraction for the same energy or same heat produced. This was the aims. And what was the solution? Solution was, okay, requirements which were incorporated into the water concessions. And we have this users monitoring, which were non-existent or very poor before that. And some of the requirements are that you have to prepare new monitoring program for every 3 years. You have to measure groundwater level, temperature, and yield of each producing well online and hourly. And you have to send this data on daily basis to the environmental agency. You have to monitor the borehole, thermal borehole productivity by regular down step tests in first year, in third year, and sixth year of concession. And here you have the DOI number for the scientific article of our colleague Luca Serians. He made the analysis of these step tests. You can find there many nice things. And annually, you have to analyze chemical and isotopical composition of thermal water, of course, and you have to report each year all this data to the environmental agency, and also you have to make interpretation of data, not just raw data. We also propose that you need to work on your energy efficiency for the open systems, and this should be more than 70%. As you see, there's a formula. It's a small formula, but you see, if you want to have 100% efficiency, you have to cool water, thermal water, up to 12 degrees Celsius to ambient temperature. Of course, this is not possible, or even it's not affordable. But okay, we have to be. So 70% is quite good. 70% efficiency is quite good. And of course, you can also optimize your monitoring program. The environmental agency said, okay, you can optimize, you can not do some isotopic composition, some tritium if everything is okay, because tritium we used only to see the integrity of boreholes. If you have some tritium in this thermal water, it means that there is some leakage somewhere in the upper part of a well. But of course, you have to do this on the basis of the interpretation of monitoring results. And how we did succeed to do all this, because it was very hard at the beginning. It was, Lenz's rule of electromagnetics. If you push the system push back, and the user didn't didn't know how to do it and why. And we had to have some workshops to train them. And now I think it's quite good. I think that this is the best monitoring in this part of world for sure. I don't know for others. And of course, from this research monitoring network started by Nina Erman. Now we said the environmental agency adopt this monitoring network, and we measure this on 4 or 5 wells still, and we see that the water level in one well still is going down. We don't know why. In the other well, we saw that first in 2016 the stricter control because of granted concession. So this trend, it was less negative than before. And then you can see how the spa closure due to COVID-19 measure, because at the time the spa was closed, how this improve the water level in one well. And here we don't know what is happening here. But okay, because of this response, we could now, we know we have very good impression what the capacity of this aquifer is, and we also know how much of this water, which is produced annually, we have to put back to maintain the pressure in the aquifer. And this is crucial because of this loose sandstone sand, because of compaction, of course, if we don't reinject, if we decrease. And then this is the current situation. All of this data, of course, is also interpreted, analyzed because of the water management plans. The European Union has a 6 years period where you have to decide if all the groundwater bodies are in good chemical and quantity states. And we see that in the first period between 2010 and 2015, the trend was, let's say, in observation well, strictly negative, in production well, let's say, stagnant. But now we see also in the success in the second period of this water management plans for most well except this one. And this, I mean, we still need to do some research what is happening here. Okay, and then where I stop, I have some to be able to answer all possible questions which regards the protection of the transboundary water bodies on the one hand, and to increase its energy utilization, because this is a renewable energy source, green transition, climate changes, decarbonization, etc. We need very strong, reliable geoscientific expertise in the form first of geological, geothermal, hydrogeological, geochemical conceptual models. And for this, first we had to establish common understanding in transboundary approach, as in each of these neighboring country, we use different names or different nomenclature for the same geological units. So first we have to come to this common understanding. And then, as you see, we start to build this geoscientific expertise step by step, slowly, or project by project. First, we start in 2009 to 2011 with Hungarians in some European Interreg Slovenia Hungary program. Then we start in this, and this we are deal with this sedimentary fill aquifer descent and sandstone aquifer, and then in the next project Transenergy, which was very in the same time, we said, okay, we will research the carbonate aquifer in the basement of this Pannonian sedimentary basin. And we did this mostly with the Austrians, with the Geological Institute of Austria from Vienna. And then a very big effort was made by Nina Arman in her PhD. I think she made a very big step. And then we, in the next project, which was also up in space project, the GeoMol, we prepare 3D geological model with the common procedure. So like in Molas Basin of Bavaria or Po Valley in Italy, also we here in our region, we made Slovenian, Hungarian, Austrian model. And then we have Danube, also Danube project. We had and the last one is GeoEra, GeoConnect 3D, where we mostly dealing with geomanifestation. Okay. After conceptual models, the numerical models follows. They are used for assessment of state of aquifers and also for some predictions. And of course, this model should be alive. They need constant improvements. New observation wells were made, new data have to be put, updating the data. And for Slovenian part of this transboundary aquifer, we have live model, but unfortunately for the whole transboundary model which is going up to Slovakia, the model is not updating from 2013 to this time. And one very nice attempt for harmonization of knowledge about transboundary thermal groundwater bodies was made in the Darling project, where we first made an inventory of geothermal sources. So we identify 776 boreholes, mostly with the average depth of 1.1 kilometer, and the amount of water per year is 62 million cubic meter of abstraction. And of course, we also see that more than 70% of wells is older than 30 years. So makeup wells will be necessary in already now. And of course, one of these, because we had a very big number of these wells or these utilization sites, we try to compare the management practice in different countries using the adapted LEC-Liman benchmarking evaluation. You can see, you have here all this data, you have this links, and then you can see what was the methodology for using for preparing of this benchmarking, and what was the indicators. And see, we start this first in this TGM project, and also we formalized, and we are now here in this GeoConnect 3D. We use also multiple use, because we know that the storage, that the development of subsurface now is very there are already conflicts of different use of the subsurface, and we also have this management indicator, technology, energy indicators, environmental indicator, and social indicator. And you can see here how this benchmarking results are. You can see what are difference, and then you can go to the report and you can see, what we are doing here better, or what doing here worse somewhere. So, and we can learn from each other, and so on. And what now? What is happening now? So basically, guidelines, geoscientific guidelines are prepared. Political and administration bodies have to step on for official delineation and declaration of this thermal groundwater, transboundary thermal groundwater body. And geoscientists from both sides of border will continue to support ministries and agencies in data exchange and joint interpretation of aquifer states. The national water management plans and reporting requirements are also the important initiation of international collaboration. We can learn from each other very much. And monitoring is yet not harmonized among the countries. We are much better than our neighboring countries. And there are proposals for at least one observation well at the border between Hungary and Slovenia. Thank you very much.
Okay, thank you, Andrei, for your presentation. So I suggest we maybe move on to the next presentation, and then maybe if there will be any questions at the end. Next presenter is Mojca Božić. She received her PhD in technical environmental protection from University of Maribor in Slovenia. She worked for 15 years at Faculty of Mechanical Engineering at University of Maribor, where she focused on the field of polymer biochemistry as an assistant professor. And currently she's working as a project manager at the Dravske Elektrarne Maribor. And her research focus are renewable energy resources and circular economy. Her presentation is about Slovenian innovative pilot geothermal power plant as a part of project SI-Geo-Electricity. So thank you.
Thank you for the introduction. So hello, everybody. Like she said, I am Mojca Božić, and today I will talk about SI-Geo-Electricity project. That is about pilot geothermal power plant on the existing gas well, PH8. So I'm coming from development apartment in the Dravska Elektrarne Maribor. With the 8 large hydroelectric power plants, Dravska Elektrarne Maribor are the largest producer of electricity from renewable sources in Slovenia. We have also 4 small hydroelectric plants, 3 at Drava River and 1 at Mura River, and 5 solar power plants. We produce about a quarter of all Slovenian electricity. Now, if you could see in the picture, the Drava River is fully utilized. So we are searching for new sources for producing renewable electricity. So we're now focus with the projects in the solar, wind, and also geothermal sources. So this is one of the first projects in our company and also in the Slovenia. It is small pilot project. It's the geothermal power plant with the capacity of 50 kilovolts with annual production of 400 megawatts hours. And here on the figure, you can see the well, PH8, which is located in northeastern of Slovenia in Lendava municipality. And well is abounded. It's a gas well. It's abundant now for more than 15 years. And it's in the depth, it's around 3,000 meters with the temperature in the bottom 155 degrees Celsius. The project started in May this year and will be finished in April 2024. Now, this will be the first demo demonstration of the completely new technology, which is patented by Slovenian patent, yes. So the project partners, we are, like I said, Dravska Elektrarne, we are coordinating the project. Then is Petrol Geo. This is the Slovenian company of hydrocarbon production. The company maintains the Slovenian oil and gas wells, and in the project, their activity will be underground works. Like I said, the work regarding to the well reconstruction. Then is the University of Maribor, Faculty of Chemistry and Chemical Technology. They will provide the modeling of the heat flow, the heat and mass flow of the new heat gravity pipe. And then are our colleagues here today, Geological Surveyor of Slovenia, the Public Research Institution, you know very well. We heard today a lot of their presentations, what they're doing. And in our project, they will build the 3D geological and geothermal model of the well surroundings, and we could look how during the production we could look how the temperature is changing from surrounding, and we could optimize. We will optimize it later. So HSE Invest is the company of engineering and construction of energy facility. Is providing consulting, engineering, and design services. And the HSE Invest is together with the University of Maribor did all engineering design of this technology. So the project is financed, it's co-financed for Norwegian financial mechanism, and we are lucky to got this financial additional finances. So I'm talking today a lot about new technology. So in the left side, you can see the most frequently used geothermal plant. It's so-called binary geothermal power plant. This is the scheme, how it's work. And what we have is two closed loops. One where the geothermal water is pumped from the production well and circulated to another reinjected well. So this is one loop, and during this process, the heat is transferred to, in the heat exchanger to the other closed loop, where working fluid, there is another working fluid with a lower evaporation temperature, and when it's take up the heat, it's vaporized, and the vaporized as a vaporized is going to turbine and then to the generator, generating the electricity. From the turbine is it's flowing, the vapor are flowing to the condenser where they condensed, and with the cooling system it's cooled and again transferred to the heat exchanger. So what you can see here, we have two closed loop, two well, one is production and one is re-injected. So, and we use water, thermal water. Now, in the right side, you can see the scheme of our new approach, where we can use only one drive well, and we use the heat of the rocks around the well. So the technology of this, our approach is based on the two pipes with different diameters put in the sealed well, and where ammonia liquid is transferred, gravimetrically transferred. We don't need any pumps into the well, and by absorbing the heating, it's starting to vaporize, and vapor are flowing back to through another bigger pipe to the turbine, directly to the turbine, which through the generated again generate electricity, and then through the turbine the mixture, not the mixture, in our case ammonia liquid, is transferred back to the condenser, it's cooled down, and again to the well. So we have closed loop. We don't use any water, any pumps, and we use only one well, which is in our case abandoned well, non-productive well. So imagine millions of abandoned non-productive wells in the world that can be used for such technology. So we don't use any additional money for drilling, we just use already existing wells. So our project activities, the first one is the well reconstruction. Now Petrol-Geo started this year on this activity, and now there will be started with the removal of existing equipment from the well. And of course, the well have to be tested for the sealness. It have to be sealed, because we don't want to lose ammonia under the ground rocks. And if it's not sealed, the sealness will be established, and then we will put another new geothermal anti-gravity heat pipe as patented or in the Slovenian patent. Now in the figure, you can see in the left, there is the situation that was in summer at this location of well, and on the right there is a current situation. The work started just in this week. They put there all the pipes, and all the machinery will be there to remove the existing equipment and to put another one in. Then in the January, we planned in the January in 2023, we will, for this activity, we are responsible together with also Petrol and faculty. And we will install the above ground part of the pilot Geotheroom power plant. So the construction work is required. So we have to build 3 new concrete bases on which the microsteam set will stand up, which you can see in the figure. This will be all in container. And then another concrete set will be for a cooling system and for the condenser and additional reservoir for the ammonia. Of course, then electrical installation together with electrical equipment will be carried out, mechanical installation. And in the end, when all installation will be finished, the system will be filled with ammonia. After ammonia filling, of course, we have to get all working permits. So technical inspection will be carried out. And when we get all the permits, then we will start to produce the electricity. And during the producing electricity, we will do all the measurement modeling, which will be done by the Faculty of Chemistry in the Maribor, and simulation of the state in the rock, which will be done by our colleagues from Geological Survey of Slovenia. And of course, long-term operation monitoring, as this is the pilot project, first kind of the world, so we don't know exactly. We did plan, but still a lot of new things can happen. And now we have to do long-term operation in order to get all the data for maintenance, for other unexpected events that can happen during the operation. Then assessment of the geothermal potential of abandoned oil and gas wells in Slovenia. This will be done by also our colleagues, Geological Surveys. They will check all, together with Petrol Geo, they will check all the wells, productive, non-productive in Slovenia, which could be potential for further use of this kind of project in the future. So we will have all technical data, all spatial data around. And for this also, the guidelines will be prepared how this project in the future could be optimized for the new investors. Yes, and the communication, of course, we also now we have new web page. You can find us on this link. Here, all the new news will be updated, all activity going on, so you can follow us here on this page. And yes, for today, because we just started with the project, I will conclude with the successful starting, and to thank all the partners for good cooperation, of course, for the financing from the Norway and financial mechanism, and thanks for organizers to inviting me to have this talk. And of course, all of you, thank you for your attention.
Okay, thank you, Mojca, for your interesting presentation. There are currently no questions in the chat, so maybe I'll just go on with Nina. So the next lecturer is Nina Arman. She's a senior researcher in geothermal at the Geological Survey of Slovenia, who acts also as head of the department groundwaters and hydrogeology. She received her PhD in numerical simulation of regional geothermal aquifer in the Transboundary Pannonian Basin, and took additional postgrad courses at the University of Auckland. Currently, she works as project leader of several national and EU projects. She is involved in hydrogeochemical research of mineral and thermal waters and gases in Slovenia, development of monitoring system of geothermal aquifers, and planning of measures to mitigate potential overexploitation of our geothermal aquifers. And today she's going to talk about supporting efficient cascades of use of geothermal energy by unlocking official and public information as a part of our new project INFO-Geothermal.
Okay, thank you, Mateja, for introduction. You hear me? Okay, cool. Okay. Okay, so to wrap up the presentations, I will talk a little bit about a different kind of project. While SI-Geo-Electricity was targeted to new pilot technology development, then we have another project which was directly funded. So it was gained as a predefined project, and it's called INFO-Geothermal. And its main focus is to enhance and especially to ease use and development of thermal water resources. So it means not only direct use, but also hopefully one day we will have a real geothermal power plant, which will be using geothermal fluid, so water circulating in several, or steam, even better, steam circulated in several wells. So this project lasts the same, so about 20 months. And it's funded by the same program, so the EAA grants, and it's actually, I think, one of the biggest, financially biggest projects in geothermal that we had in the last at least 5 to 10 years, except for drilling the wells. But first, I would just like to talk a little bit about our geological survey. So present what is actually our field of expertise. You already heard from many of my colleagues what they do. And we are actually a rather middle-sized public research institute of Slovenia. We are situated only in Ljubljana because if you drive to the borders anyway, you have only 2 hours. So we do not really need regional branches at the moment. And there are about 120 people employed here. And our main assignment is to gather any subsurface data which is available in Slovenia, process it and make it available for users to be able to use and use in a sustainable way our natural resources. And to do so, we have many research programs and projects. We are also quite strong in European type of projects. And we have, so on the lower right side, you see different data sets, so different type of public information which is available at our website. So it's either geological data and reports, or the boreholes, or the field measurements. We have different monitoring systems managed by our own. Then there are geohazard maps and the mining book, which is actually run by us for the Ministry of Infrastructure. And our department, so most of us today come from the groundwater hydrogeology department, is one of the biggest here with more than 30 people. And of course, because it's hydrology, our main topic of exploration are water resources, especially drinking water. However, because thermal waters have been up to the last 5 years, the greatest topic in geothermal, of course, is our expertise too. And as you heard today from Andrei, especially, we are already have a lot of expertise in managing transboundary aquifers, not just cold water, but also geothermal waters. And within this, there is a research group, Geoenergy. This one deals mostly, but not only, with geothermal resources. So both shallow, as already presented by Simona, and deep geothermal, where we regard use of thermal waters. But we also investigate like fossil resources from coal. We do have still an open coal mine in Slovenia, in Velenje, and we also still have oil and gas fields in Lendava or around Lendava, and we also have a nuclear power plant. So there is always some research, especially now connected to its safety and building a new block. But going to geoenergy and geothermal expertise, you could see there is a list of all different measurements and field tests we do. And so we try to go from the field work and laboratory work to numerical models, which were today already presented, and use the results of these models and scenarios to make it easier for decision maker to decide in which way and how they should support development of geothermal in Slovenia. So what we do in Slovenia is that and where geothermal comes into real world is that we are really struggling to increase energy efficiency of our building sector, which means that we have already reworked many of old buildings, so they use less energy. And now we are already, or at least try to be in the second phase, where we could start using geothermal. And there is a fact that we have, I think, 93 district heating systems in Slovenia. However, only one of them uses thermal water to heat the town. And there actually was one more a few years ago, but they stopped using geothermal in Murska Sobota because of different reasons. So now we have only one of 93. So we could definitely say we have a lot of work to be done, and we could spread this type of energy to already existing systems. And there are also many challenges addressed here. Of course, nowadays it's very important to get enough people which are properly trained to develop some topics, to connect, so this intersectoral cooperation. And we actually try to provide maps of potential so they could feed then to these technological and technological projects. And so we tell the administration also how and where to support these projects by different tools. So the geothermal, INFO-Geothermal in brief, it's a new project worth of about 1 million euros. And there are 5 different partners, and we think it's a great success that officially we have connected the research, so us, geological surveys, and the 2 ministries which take care of natural resources or geothermal use in Slovenia. So MZI is Ministry of Infrastructure, and they control the mining permits. So if you have a geothermal doublet, they give you the permit. And then there is MOP. This is Ministry of Environmental Spatial Planning, and they give you concession to use thermal water mostly without reinjection. So when you emit it into the environment. And then we are also connected with the Association of Municipalities in Slovenia, which are more than 200, even though we are a small country. So it's a big challenge really to address all of them and to give them sufficient information to develop. And our Icelandic partner, so it's Iceland School of Energy of University of Reykjavik, and they provide mostly the training to our group to see how it can be done and just give us some ideas where to develop. So the main results of INFO-Geothermal will be actually really concrete guidelines how to support efficient cascade use and to make all information. You saw already with Andrei's presentation, there is a lot of projects which were done, but usually this website dies after 5 years. And then there is, the information is not more publicly available. So we try to overcome this and to make really all already gained information publicly available, but also to upgrade this to additionally and in small scale map this technical potential with new 3D models in 2 selected pilot areas, so 2 different municipalities with the highest interest or the highest potential, and put this into official websites of the ministries. And what ministries will do is this first part. So they will prepare how we should change the legislation, what kind of risk insurance schemes can there exist, especially for geological risks and for drilling, and of course, how they plan to subsidize this efficient energy use, so to support injection and cascade use, and hopefully even to produce electricity, or first we have to do sufficient research for electricity production from geothermal fluids. And about the know-how, so what we hope to have in 2024 is to have an official Slovenian national geothermal network, so all this information can flow really much faster than now. We already had, last month, we already had a training in Iceland. There was more than 20 people from Slovenia there, from different kind of experts. And what we have learned there is that, of course, everybody knows they have quite high temperature fluids. However, because of that, they do not really work much on energy efficiency. So in that case, they could actually learn a lot from us. And they also have similar problems, like I suppose all over the world, with social acceptance. So it means even if they want to develop a new site, there is of course visual impact. There is a possibility of microseismicity if you do reinjection. There is possibility for pollution if you do not reinject, and so on. So they have, even though they have a very strong business support sector, so they have a lot of agencies which support to develop these projects in geothermal, they do have also a lot of challenges where they could explain us how they do it. And next year, we plan to return this visit, so they will come to us for 3 days and see how we do it, and hopefully already improve something in Slovenia in about half a year. Now I would like to take the opportunity to invite you, or especially to encourage you to invite your students, if you know any which are interested in geothermal, to the second International Geothermal Summer School. The first one was held last year in Ljubljana, and the second one will be for 6 days in the beginning of July next year. And this is actually the only official geothermal program which is going on in the last years in Slovenia. They could actually get credit points on a master level, and there is no fees, of course, to attend. And there will be even some scholarships available to travel and accommodation. So we plan to publish the first information very soon, but there is already a contact email established. So if you have already any other questions, you can just email it. The plan is to have, so 6 days. 1 day is a field trip, then 1 day is student conference, and the other days there are field work, so they have to do a lot of work by themselves, and then interpret the results in the lecture room. And then also there are student projects in the afternoon, so it's really very interactive, and you have to think and cooperate with other guys which do not have to be already in geothermal. So the main point is that we want to attract more people into geothermal, even though they have been studying or they have been doing different things up to now. So yeah, just keep it in mind and follow the news also on Geological Survey website. And maybe what will be useful for you in long term is that since we will develop all these guidelines and digital data sets, they will be publicly available. The website is at the moment just the second one is at our server, but the official from the ministry is not yet established, but these are the 2 links where it will be very soon. There will be also a video and booklet available for investors in Slovenia. So if you will know anybody and they will be interested in this part of Europe, just send them the link when it will be available. And if you will visit us, there will be at 10 user sites, so at some greenhouses, at some spas, there will be informational boards on how they use geothermal in an effective way. So we also try to do this in the industrial tourism and promote the sites, that people do not only come here to have a bath, but also to really think about where this energy for the pools or for heating of the hotel comes from. More or less, this is it about the project. So it's the same program. And if you have any other questions, you are welcome to write me and we will be in contact. Okay, thank you.
Okay, thank you, Nina. So now maybe we can go to the questions, or actually you already answered most of it, but maybe we can just go through them. So there was a question for Dusan, so about the 2 wells drilled for a double, but not in use. What is their current condition? Why are they not in use? And Dusan then wrote that those 2 wells were drilled in Murska Sobota and are perhaps too far from each other. So there was some testing done, but they're not really sure about the details. And they are not yet in use due to permission difficulties. And then there was a debate about what kind of programs you can use. So is there an alternative to FeeFlow? And so if anyone is interested in those programs, maybe you can take a look at the links that people sent in the chat. So it's pretty interesting. So it's there are also some open source things. So maybe you can take a look, or if anyone has any other questions about that or any other presentation, please go ahead. Okay, or otherwise we can slowly finish with our event. So thank you all for your participation. I hope you heard a lot of new and interesting information. So have a nice day. Yeah.
Thank you. Bye.
Sorry, Peter, you raised your hand. No, nothing. Okay, then that's it. Sorry. Okay, goodbye. Bye.
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 Bye-bye. Thank you, Mateja, for leading this event.